What is up? So you've seen the title, you're probably thinking, what the hell? So this is an area, this is in Glendale, where it has a lot of that scary rooftops, right? And then it also says, and some scary 5G. Well, let's kind of get a revisitation of what scary rooftops happen to be. Well, it's all these rooftops under the greater wisdom of the developers here, architects and engineers and everybody involved, decided to stick rooftop AC units up on the roof, two-story homes. They give a little strip of shingles while the rest of it's tile and expect you to put your ladder right there to get up to the unit. Now, I used to service some of these like 20 years ago, 25 years ago. It was always pretty crazy and sketch. Even on jobs like these backyards, you'd barely get your ladder in there to get up to them. But a lot of them here, as you'll probably see, I'm sure if I go through here, are going to have some full retard setups where there's like, here's one where you got one rooftop level below the other one where the ladder's supposed to go. So notice everything else is tile except for the strip of shingles. But where are you going to put the ladder? Let's go look right on the side. Well, your ladder needs to go right where that second lower rooftop is, but so if you stretch the ladder out, it's too much of an angle. Now, when I did service these, and I wouldn't do these now, no way in hell, but when I was younger and dumber, I should say, or more willing to risk my life, I would just tell them if I'm going up there, I'm going to go to the easiest part to get on the roof, which was usually the lower level, like over here, and then I'll walk up and over to your unit. But one reason I would never freaking go there anymore is just, well, look how ignorant these are. You know, it's an angled roof. There's no catwalk around them, no barriers for fall protection. And, you know, as you can see, you know, you're standing right on the edge, literally, where you have to pull the cover off the AC compressor. That one's really close. And when they're not all that close, and like this, we're a little closer to the peak, well, they still always had the condensate pipes, the whips for the electrical, all just crisscrossing the units. And if you weren't paying attention, you could trip on one of those. So it was always just, I was always mindful of them, but you always had to make sure you just had to remember before you ever just moved, turned around, anything, that you didn't forget and trip and roll off one of these two-story rooftops. You see, these are pretty crazy. So these ones a little further up, but there's plenty of them that just by the nature of it puts it right by the edge. So I've made videos over the years. Some of them were way back before smartphones. Some of them were with the early smartphones, so they're kind of not as good quality. And then once I started getting a good camera, I started getting a little better ones. And then the drone, of course, gets me up there from this nice aerial view. Here's some more original units, probably old Carrier 50 YQQQs, whatever the model was. These units are like absolutely bulletproof, thank God. But when they get older, the wires, you know, start rotting, and that's literally what eventually causes them to start breaking down. But look at these. I think these are original units here, and that's how they were from the get-go. They expected someone to put up a ladder all the way 2 floors up, 2-story rooftop, go up there and stand right at the edge of the rooftop to pull the cover off of that one access panel right there. And then you got the 2 side panels. Just absolutely freaking nuts, man. It's hard not to drop the F-bomb when you speak of these jackasses, but I'm not talking about the architects, builders, developers, everybody freaking responsible, and Maricopa County for, you know, never enforcing any safety rules. They'll do it, you know.
That's crazy though, how they never was like, hey, like, yeah, this is unsafe.
It's blatantly unsafe. The only good thing California does, possibly, is that they don't allow this. You have to have anything like this. It's going to have rungs actually going from the edge and up to the unit, and then a way to climb up onto a catwalk. And a catwalk will have the, you know, 6-foot high, you know, barrier around it, fall protection. Yep. So let's go. So I can get this all in one battery pack. Just kind of show you something funny. Just gonna bring it up to bring it up. But in this area, in my area too, I'm a little south of here. You know, they got a lot of the new 5G cellular stuff. Now, of course, when a lot of people show 5G, they get all, and they're all trying to get everybody afraid of it. They always show pictures of the old-fashioned, you know, the normal cellular towers. Probably put one on the screen here. You know, those are the old school. These new ones are basically glorified Wi-Fi, not very powerful. They have to have them installed very closely together. So if we go down this road, you're going to see several of them. Every couple hundred feet, there's going to be one within 5G coverage, and that's because the upper frequencies that are in the 5th generation, that's all 5G stands for, is 5th generation wireless, and they repurposed a lot of frequencies that have actually been used for many decades. Old C-band, satellite TV, been repurposed into it. You know, like I think Verizon runs some of their bands around 39 gigahertz. There's frequencies that are way lower that are within 5G that like T-Mobile was first using, not even in that frequency band that everybody's freaking out about. But this is like becoming a more common style. Now, I think if you have T-Mobile or Verizon home internet, which I actually do now for Verizon, it's going to be coming from like one of these devices somewhere. They have to be pretty local. Higher frequencies do not pass through walls as well as the lower frequencies. They don't go as far because, you know, they get grounded out, absorbed, you know. So you have to have them frequently, you know. You have to have them everywhere, basically, just like you do with your Wi-Fi. It only goes so far. These have more power than Wi-Fi, of course, but let's get over there. And there's like another one, I think, right up here. Yeah, they're close together when you get good coverage. And there's another one right here. So these, you're going to see these sprung up, and they're kind of on with the stoplights here. Sorry, they're kind of on the same pole with the street lights. So there was a video a couple years ago, and I always like get a crack at it, you know. But someone was working on an LED street lamp, like a hybrid. It wasn't quite one of these separate, you know, on the top, you know, 5G home or whatever this is, but it was like it had some wireless in it. And the guy was claiming it was 5G, but he was showing the circuit board in there for the power supply, and it had like a 400 volt capacitor in there. And the guy's like saying that means it has a lot of power, which he really didn't know what he was talking about. It doesn't really mean it has a lot of power, but he was saying the only reason there was a 400 volt capacitor in there is because it was a direct energy weapon. It was not needed for the light. Well, if you knew anything about the power supplies in anything that runs off of utility power, so this could be 277 volts, you know, for example. But even let's go to your home unit. You take apart one of your cell phone battery chargers, as small as they are, you're going to find a 400 volt capacitor in there. And the reason is they rectified the AC to DC, and it's going to be about 330 volts if it's got 240 volt input. And you'll say, wait a minute, 240 volts, 120. Well, in the United States, we use 120, but you'll notice that all those power packs like that, all the buck boost type, they all run like 100 to 240 volts. Anything within that range could be your input. It charges the first capacitor, which is the first stage of the power supply, and then from there, then they have the other step downs using usually buck type conversion. So it could be 5 volts, 12 volts, whatever. And that's what you can find in those. And I can show you a couple on screen of stuff I've taken apart here. So I'm back home at the laboratory working on some of my motion lights. Just replaced this one because this one died. It was pretty bright for a Harbor Freight special, but this is a good opportunity to kind of show you how power supplies are. So this one's a 120 volt AC input. It's not good for putting, you know, European, you know, 240 volts in, but you'll notice that the first capacitor, the primary one there, this will focus, it is 250 volt capacitor. There it is, 250 volt capacitor. Then after your step down, you got a 25 volt. That's the working voltage. Usually you want to be higher than what you're at. So 120 volts AC, that is RMS, an average. It's pretty close to about 170 volts peak to peak. So if I put the meter on there, and that if that rectifier is good, you're going to see that. And after some sort of a regulator, it's going to drop down to, you know, whatever that supply is. On this side, it's going to be, you know, less than 25 volts. Cool thing about this meter here, this amp probe, is I could put it in this one mode that will switch between AC and DC automatically. Turn the power on. This is the line voltage coming in right here. So you have a fuse here, 120. Fuse is good. This meter can switch over to DC automatically, so if I'm careful, it looked like that was plus and minus. So 171 volts, 172 volts. Yep. And I think this is the second capacitor. It's 20 volts, it looks like, so it's kind of consistent voltage I'm getting. 20 volts and a 25 volt capacitor. And that's what it is. And I would make more of a video, but actually when I looked for the original video, I can't really find it anymore, but I saw that some other people have covered it, and one other guy kind of basically says the exact same thing. He's showing household power supplies for various things, and you're often going to find, just because you're always rectifying the sine wave, you know, the 120 volts is actually 120 volts RMS, and peak to peak it's 170, so that's what that capacitor will charge to. If you put a 240 volt input like in Europe, it's going to be about 330 volts DC, so you need a 400 volt capacitor in there. But there's a bunch of these things over right here. And the thing is, and this one here down here maybe give you a little better idea, but there's an array of like hundreds or even thousands of antennas in each one of these things. And the nice thing is they can use, so say I'm here and I'm on this, connected to this cellular deal here, and there's one going each direction here, but they could kind of like use it a phased array, using phasing of multiple antennas. They could kind of steer the direction of the output signal and also the sensitivity of receiving it. And I think they have different kind of technology. They call it like MIMO and all this different stuff that's been, you know, evolving over the years. But basically, you can steer the energy, and that's what the people that are actually wrong on this conspiracy. There are good conspiracies, but this one's BS. Well, I'll probably piss off people with this video, but there's just not enough power for it to be a direct energy weapon. But also, the reason that you're focusing more than one antenna on any particular person's to provide, you know, the better quality of signal and coverage. But that's, so if I'm connected to it, it could be like, you know, there could be like a bunch of nodes connected to me, not just one antenna. It's got a bunch of them, and it gives me good signal quality. Now, an effect that happens is on one given cellular device like this, if the more people that are connected, the less that it can focus on each person, and then you get less effective range, coverage, signal quality. So once you get a lot of people into a certain market, you get coverage shrink, quality goes down. You gotta beef these things up, you know, put more of them in, whatnot. So anyway, I was just kind of, I don't want to say mocking, I'm not trying to make anybody mad. I'd rather people that are aware, let's say, but they kind of jump the shark and go to the craziest, you know, unfounded conspiracies that they just kind of learn the truth about them. All sorts of, you know, radiation and stuff is cumulatively harmful and stuff to some degrees, but it's not a direct energy weapon. It doesn't have the capability to be of a direct energy weapon, and it's not even running at 60 gigahertz like people were all freaking out about, which is you know, basically what vibrates oxygen molecules. 2.4 gigahertz is what vibrates water molecules, which is why we use it to cook in the microwave oven. The funny thing is, a microwave oven could be 1,000 watts, and while it's bouncing around trapped in the microwave oven range, it will cook your food. However, if you open the door to a microwave oven and defeat the safeties and turn it on in your house, you'd have to run the shit out of that thing for it to harm anybody, because it would scatter so badly, be absorbed by the materials in the space, and that, you know, it wouldn't be an instant effect or anything. It would just be a cumulative and harmful over time. I've known people that would actually stand right in front of the path of a magnetron, you know, from a microwave oven. And I used to always be real careful. I used to repair them, like in the 91 when I was in school or whatever. I had a job for a while repairing them in a shop, so I was always real, you know, made sure I had the door closed, safety's working and everything. But later on I learned that they're not quite as immediately dangerous as people have you to believe. You still don't want to have the leakage in the long term. That's the key. So here's another one. You'll see that these things are just everywhere. Let me go down a little further, but I'll probably start losing signal. But you're going to see that in all these markets to make these work. 5th generation wireless is going to be every couple hundred feet or so. Sometimes a little further, but when you have a lot of homes using them, you know, coverage shrink again, you know, trees, buildings, it doesn't pass through it as well as the lower frequency ones do. So right at the end of where I get a good quality on my drone flight. And it's making the controls a little sloppy right now. It'll clear up here in a second. Yep. Let's cancel the beeping, which is going to drive you guys nuts. Anyway, right here, I mean, like I said, there's lots of these scary rooftops right here. Just tons of them. This is Glendale. Peoria's got the same thing going on. I've done some of these already. But I just want to make this short little video here just about how nuts that is. Okay, that shut it up. Well, I didn't want to touch the button on the drone back there, so I might just edit out all that beeping and skip up over here.
Well, I will save you guys the torture of the low battery beep, which is a two-tone beep, much worse than the fly home beep. So don't forget to like, share, subscribe, and all that stuff. Catch you guys later.